into it. New York Augmented Reality. Do you see my screen, Barry?
Looking good, Lady Liberty.
We disabled the ability to actually welcome to New York Augmented Reality. It's really nice to have you here. Thank you all for joining. Dave, good to see you. Shuli, always a pleasure. Elia, Keem, thank you for hopping on. Amazing to see everyone. Speakers, Samantha, Wolfe, Neil Weinstock, Nils, Pihl, and Chris Grayson are here, and we're excited for them to learn more about their work from them tonight. Due to some spam at past events, you are not able to activate your camera or unmute your mic. If things go okay, we can open up access, and at the end we'll open it all up as well. And Barry, Seth, without your help, this event would not be possible. So if you could say a few words of wisdom to the group, that would be much appreciated.
Words of wisdom. Well, you screenshot me. Well, just wishing everyone early July 4th weekend for those in the States or out of the States, America. And, looking forward to hear about all the new things coming out in AR. Some really amazing guests and, new visitors. Thanks, Nguyen, for joining us, and as well as some people have been here for many, many times. So rock it on. Thank you.
Nice. Beautiful. Barry and I worked hard on tonight's event, and we have some incredible speakers tonight. So thank you for joining and supporting the New York Augmented Reality group. And agenda for tonight, I'll go over the Meetup latest news, then we'll have presentations. We'll hear from Samantha, Wolfe, Neil Weinstock, Nils, Pihl, and Chris Grayson. And next month, we're hosting an in-person meetup at NYCAP 3D in Brooklyn. So we hope we can make these events more consistent, and we really hope you could join us. We're going to charge a $10 admission fee. Well, that's flexible. If you feel that's too much, put it in the chat. And we'll do that and see how mad people get. The reason for the fee is threefold. First, there's limited space, and we want to legitimize the meetups RSVPs, so people don't RSVP and not show up. Second, it will encourage us to create a better event that is worth the money you spend. And lastly, we'll be using all of the proceeds for food and drink at the event. If you have any thoughts or don't like the idea of paying for a meetup, let us know in the chat and we can work on other solutions. So you can RSVP on meetup.com. It's not entirely, the payment system's not entirely working yet, so you'll have to check back as well on another date. Other events, Kagami at the Shed by Tindrum is a mixed reality concert. There's a Woodstock Hausen is an experiential music and visual festival in upstate New York, July 7th through 9th. In London, the Audio Engineering Society has a spatial and immersive audio conference on August 23rd at the University of Huddersfield. SIGGRAPH Computer Graphics and Techniques Conference is August 6th in Los Angeles. And also in London, Acute Art and Royal College of Art are hosting a course that is, just to quote them, an introduction to the fascinating world of virtual and augmented realities and how they are changing contemporary art and its institutions. And you could interact with artists like Oliver Eliasson and Cause and Rodrigo Marquez, the CTO of Acute Art, through this course. It's paid, but it's in London. It's cool. Next, Qualcomm and Alliant have an incubator. So if you're a developer and you want to be part of the program, you can apply until July 16th. I'll post some links afterwards. Funding. Red 6 raised 70 million, Series B. MetaViz raised 20 million. Nreal rebranded as XReal and is hosting a new Series D round. Squint raised 6 million. Suave Photonics raised 3 million. ARDK 3.0 came out. It's compatible with AR Foundation and also an improved developer experience for building location-based AR. There's a GitHub repo from Cavix is a wonderful list of game development resources, according to the developer. A bunch of good resources there, so you should check out. And then Snap AR launched a learning hub for free lessons to create AR in Lens Studio. New headsets, Apple released Vision Pro, which Samantha is going to talk more about, and we look forward to it. Meta is going to launch the Quest 3 headset consumer grade being priced at $499. And then Lenovo announced the VRX and Enterprise headset. Now, without further ado, I'm excited to move on to tonight's presentations with speakers who are all working hard to push the industry forward and making what was once impossible a reality. After each presentation, we'll have a 5-minute Q&A. So if you have a question, put in the chat and Barry and I will collate and give it to the speaker. We're excited to have Samantha Wolfe here, who is going to share more about the Vision Pro headset. Samantha is notable in the industry. She's also the founder of Pitchfwd, the author of 2 books, Metaverse, See Beyond the Hype, and Marketing New Realities, and was also contributing author to Charlie Fink's book, Convergent, and she's presented in many conferences, and she's advisor for many different products, and she's also been the judge for CES Innovation, South by Southwest, MIT Reality Hack, and overall, it's a pleasure to have you here, Samantha. Thank you for joining, and we look forward to learning more from you tonight. Thank you.
Thank you. So let me pull up the presentation. Hold on a second. We had it before, and then of course it went away. Let's see, escape full screen. Okay. So what I wanted to do today, or what I was asked to do, is okay, let's go back. Sorry about that. I was like, getting it ready got me less ready than I normally am. So what I wanted to do today was basically get people relatively up to speed, if they're not already, about what happened this past few weeks, because effectively this Apple moment that people have been waiting for years and years and years of, like, eventually Apple will have a headset and like this, all these changes will happen and everybody will understand what we've been waiting for. In theory, that happened this month. So basically what I'm going to do is give an overview of what that presentation, or that part of the presentation, was like, and what certain things in it were exciting to find out, and other things that we don't know yet, and we'll go from there. So it was the June 5th event at WWDC, and this is sort of after Apple announced, which it normally does, like all the different new evolutions of the products that they have. It was sort of, I mean, I know that I was there sort of watching and was like, when is it coming? When is it coming? When are they going to announce it? Because they had invited so many people from like AR, VR community to and journalists, so you knew something was going to happen. And then this is what happened.
It's already been a big day, but we do have one more thing. This is a day that's been years in the making, one that I've really been looking forward to. I believe that augmented reality is a profound technology. Blending digital content with the real world can unlock experiences like nothing we've ever seen. So today, I'm excited to announce an entirely new AR platform with a revolutionary new product. And here it is.
So
It's already been.
So basically Vision Pro, yay. And it's sort of funny because, I work in, branding and marketing strategy. And for years I've made fun of the like beauty shots of the technology up in the air, in the black, in outer space, just like floating. And you go, what, huh? And like this one, I was eating it up. I was like, yes, bring it on. I love this design. I'll have more. So it's a little ironic that that's what happened here. To just make sure that we're sort of like covering some of the information that happened during that particular meeting. I talked about design, the hardware and the features, user interface, the applications, developer tools, the batteries, safety standards, what's going to happen with launch. They ended on the price, and not inexpensive, $3,500 US. And there's just like lots and lots of information. So if you're really into this kind of technology, it's worth watching the whole thing. But this is sort of like a cheat sheet of what happened, with a bit of biased excitement from my standpoint. What happened during, I got so excited during watching this, and granted, my enthusiasm was sort of like tempered going in. I was like, there's no way I'm not going to get that excited about this. And then instead I got like super excited and wrote this post that was like 28 points about why this is really exciting. And that's where Andy reached out and was like, do you want to just do a talk that says some of these points? And so that's really what this is. It is a 10-minute read. This was like, probably talking more about it than the actual thing itself. But so what I'm going to try to do is consolidate my 28 comments in 10 to 15 minutes. We'll see if that happens. I'll get cut off if it doesn't. Okay. So here's a little part of the next part of that sort of video. It's not all of it, obviously.
Introducing Apple Vision Pro. Vision Pro is a new kind of computer that augments reality by seamlessly blending the real world with the digital world. It's the first Apple product you look through and not at. Vision Pro feels familiar, yet it's entirely new. You can see, hear, and interact with digital content just like it's in your physical space. And you control Vision Pro using the most natural and intuitive tools, your eyes, hands, and voice. With Vision Pro, you're no longer limited by a display. Your surroundings become an infinite canvas. Use your apps anywhere and make them any size you want. Capture photos and videos and relive your most important memories in an entirely new way. Watch your movies, shows, and sports, and immerse yourself in games on a giant screen surrounded by spatial audio. And connect with people as if you're sharing the same space. These are just some of the ways that Vision Pro blends digital content into the space around it.
Okay, so you got a little bit of a sense of what's going on. So, great, it's amazing to know that this is happening, but what are some of the takeaways from this? Of like, and one of the big ones is that this actually looks like an Apple product. I said it's like taking an iPhone and putting it on your face, and then taking the watch band and expanding it and putting it on your head. Like, it looks like it's part of it. Yes, there's a lot of talk about it. It looks like a ski mask, and it does, but sort of any VR headset, or most VR headsets, look a bit like a ski mask, so that's not entirely different. The idea of some of these tech advancements that have happened are pretty amazing. They said there was like 5,000 patents that were filed. I don't know how much of it is being used in this particular amount, and all the sort of specific tech specs, but it just seems like it's not like an evolutionary from a tech development standpoint. I think the use cases are sort of similar that they've shown, but I think that we'll be able to see exactly how much more advanced the technology is, like these 3 lenses that are part of the display, and how much of a difference it does. I think that there's been other headsets where you try it on and you're almost like making excuses for the headset while you put it on. Well, the field of vision, this, well, you can't see that. And this feels like going into it that there's going to be less of those kinds of excuses as you put it on. Lots of emphasis on spatial audio and accommodating to your environments. Now, some of the interfaces, at least for me, it was sort of like, oh, okay, this seems like my computer. Like, oh, well, like, okay. And it has some shadows, which gives a little bit of depth. It's great, sure. I mean, I think we need to step into spatial computing, having some familiarity with what that interface is going to be like. But it feels a little bit like, well, I could sort of do this on my computer, which is, you know, similar with having, you know, the screenshots of people in the room. It's like, okay, or like the videos of people in the room. It's like, great to see them spatially, but did you really need it? Did you not? I don't know. It feels like we're still sort of not yet at that advancement or where we go from advancing computing. This sort of wide screen experience looks like it could be fun or interesting. The automatic dimming of the world around you, that also sort of, it seems like a feature that we could love or hate. Like you put it on and it gets dimmed and you're like, do you want that to happen or not? We're going to figure that out. Screens on screens on screens. We're watching screens with screens on our face. That's one of the things that they said is going to happen. But you can see out the screen. So you're looking at a screen and then somebody sort of pops in through the cloud of like, oh, you wanted to talk to me, which if anybody has sort of had conversations with people while you're wearing a VR headset, that might be convenient. Although how sensitive that is, like, are you walking around and then you're constantly seeing people, or are you walking around and it's like only when they reach a certain distance from you? We'll find out. And everybody gets an avatar. This, I teach one of the classes that I teach is on avatars and virtual beings. So I was super excited that there will be these sort of avatars that are a part of what you're doing. Even if there's been debate about how high quality the avatars are, but this sort of seeing the eyes within the screen so that if somebody looks at you, they can see your avatar eyes. If you're having a conversation from the headset that they see your avatar, it will, I think that as more and more people try the headsets, we'll end up seeing whether this is a amazing feature, that how did they actually figure this out, this is such a great solution, or people will be like, weird avatar eyes, like if it glitches or something, which hopefully it won't, that kind of thing will get a sense of it. But I was, you know, cheering on the future avatars of all of us. There was also this idea of like, we're introducing spatial computing, which to anybody who's been in the industry is like, introducing, interesting. But here's a little bit of that.
So in the same way that Mac introduced us to personal computing and iPhone introduced us to mobile computing, Apple Vision Pro will introduce us to spatial computing. This marks the beginning of a journey that will bring a new dimension to powerful personal technology. There are certain products that shift the way we look at technology and the role it plays in our lives. We believe Apple Vision Pro is a revolutionary product with the performance, immersion, and capability that only Apple can deliver.
Okay, so it is not the first time that people who are within the industry have heard of the concept of spatial computing, but it was definitely introduced that way. I'm okay with it, but it was sort of funny that I was like, when I first joined the industry and a lot of people would complain about like, oh, VR, AR are new technologies. They're like, no, they're not. They've been around for many, many, many years. So it's interesting to see it happen again. So there's things with the spatial computing, there's more 3D models. I got sort of excited. This like model was pulled out of the interface and you could like see it. I thought that was really nice. And there's also been a little bit of debate about this idea of the 3D spatial video capture. The the dad that was doing it was considered creepy on social media. They're like, why is that dad doing like creepy capture of the kids? And I was like, okay, fine, like whatever. I do think that this like Tony Stark like 3D capture experience is going to be really fun to see if it works, because if it works, that could be amazing to capture and then sort of like go into the space. And if it's as easy as they're making it seem like, there could be sort of really fun fun things shared about what people have seen and experienced, and probably some really terrible ones like the beginning of YouTube. Okay, and they call it the most advanced personal electronics device ever, and there's probably some truth to that for sure. So some questions remain, or at least to me, they do. This guy like purposefully like came in right in between those screens, like, oh, because he knew where they were. No, of course he had no idea where those screens were. So what happens when you like go through an image that wasn't 100% clear? It wasn't clear how much was consumer versus how much was enterprise. There was a lot of work being done on couches. Like, oh, I'm gonna just do thing on a couch and with my little finger moving. And it's like, okay. And I wanted to see, because there's been so much about like hand tracking and the impact of hand tracking on interfaces. And I want to know, is it really that easy? Are you just tapping or are you not tapping? Like, what are those kind of interactions? I'll be excited to see. They had this thing where you went and like the person was wearing it and went into the refrigerator to grab something and then went back out. It was sort of a cute concept or idea, but it was like, there's a bit dystopian of like, you're going to wear this everywhere. We shall see. Maybe it was just because it was convenient and easy. And I have to say that there was a lot about having meetings in hotel rooms. They're like, so when you're in a hotel and you set up a meeting with a conference, and I'm like, probably if you're at a hotel, you're on vacation, which you shouldn't be having these big meetings, or you're about to go to a conference room. So why would you have it? I could be wrong, but there was just a lot of like, in hotel room, you could do this. I don't know. That was sort of an interesting marketing choice. And on airplanes. Now I know that there's a lot of, lots of companies that, or not lots of companies, but there are companies that have tried to encourage wearing headsets on an airplane. And that's great. Actually, she's wearing the same sweater as the woman who was in the kitchen. That's sort of funny. But we'll see. We'll see if it happens. It was Bob Iger from Disney was up there and saying like, Disney is definitely involved in this. And then it was like, there wasn't really announcements of apps or how or where. It was like, we're involved. It's like, okay, awesome. Really excited to see what you're going to do. I had to put Baby Yoda because I love Baby Yoda. And then there were examples of apps. These are screenshots from all the 3 ones that it's sort of like, okay, you can use it from an engineering standpoint and creating a small digital twin model. You could use it if you're in automotive, you can use it in medical. None of these things are new. They are all exist in the world. So, and I think that by not calling out any particular app developer or any particular app, the apps are just not there yet, but that's okay. It's just launched. But it was funny because it was like all of these are pretty like typical apps. So we'll see what comes next, which is really exciting. And that's actually what it is, what comes next. I did make some guesses really from my marketing and branding, perspective and overall business strategy. And I put 10 more of those in here, but in another Medium post. And yeah, that's it.
Thank you, Samantha. That was excellent. I appreciate you sharing. Now I will pass it off to Barry Seff with some questions.
Yes, thank you so much, Samantha. Yeah, it's really, really awesome. Like your reactions. Samantha reacts. Cool. I think you have a new, YouTube gig. So in terms, there were a couple questions about Oculus VR. How does it compare to it? So, as for your experience, how does it compare to like Oculus VR pass through?
Yeah, I mean, I think that there's so few people who have tried it. There's a really sort of fun video that was like Robin Roberts from ABC News was trying it and talking about it, which is like, that was sort of a great, I think, decision from a press standpoint of like, get some like real people, granted she's from ABC News anchor, but like get some other people to try it. And the point is that it is really a pass-through. And I don't know if I've necessarily tried anything, and I've tried lots of headsets where the pass-through is a real pass-through. And so that's, I mean, I think that that's what I've heard, that it might be that finally, that sort of like, oh, and eventually we'll have a VR and an AR blend of two technologies. And this is like, wait, did they just do that? Did Apple just do that? And that's what it seems like, but we will find out.
To be continued, yes. Greg has a question. I'll try to decipher this. What about this orientation on fitness to drive? I think he's talking about the maybe the divergence accommodation effect, or just overall human factors of there,
I mean,
about to drive that is found. To drive, I don't know if he's talking about driving. I don't think you would drive with this device.
Well, this
on.
is
Maybe
there's a whole thing
usability.
about driving. I don't know if you ended.
Oh, okay, so yeah.
No, not necessary for this one, but just in general, the about whether people will actually put this on the drive. If it's real time, if it's a real time technology and no lag, like, will people put on the headset and drive? And
I would hope not.
and well, no, Jeremy Bailenson from Stanford Human Interaction Lab actually wrote a whole article of like, please don't wear any headsets to drive.
Good.
Like, and all the reasons why you should not. And it was like, for me, I was like, why would he think that? But maybe he had sort of a sense of, if you get into a real-time headset technology, that people just might want to just put it on and sort of go like, oh, I guess I can do it. But, you know, who knows, maybe in the future we'll have like, do not drive, like in some sort of manual, do not drive while wearing, you know, we'll see. But I think the promise of a lot of this, although it's not written anywhere, is that a lot of the sort of quirks of augmented reality and virtual reality headsets as we know it will go away with this headset. Now, it doesn't mean it's going to be perfect by any means. There's going to be weird things. Like, I still imagine like your avatar's eyes doing weird things, and then people showing that on social media of like, look at my strange eye thing. But it's sort of fun that there's going to be certain things that are going to be like, oh, that used to be a problem. Oh, not anymore. Like, that used to be a problem. Oh, not anymore. There are going to be other problems. It's not, but some of the ones that used to exist won't anymore. Granted, nobody, like, yesterday I was talking to somebody who was in the like finance industry, and they're like, why am I going to buy a $3,500 headset? And I was like, you are not. Like, that's what's so confusing right now. I don't think there's like consumers that are necessarily should be buying it now. It's being sold almost like a consumer headset. But I think they're just trying to figure it out. I also am dying to see what happens in the Apple stores, because they said that they're going to set it up. And I've yet to go through a demo experience in a store with a headset. And I go in and pretend I don't know, which is sort of fun. And then eventually I can't handle it anymore. And so I'm dying to like go and put on the headset and go like, what are they going to tell me it does? How are they going to explain AR and VR? How are they going to explain all of that? And it's a good reminder of how little people know about all this. But
I think it's going to be a big thing, just going in the store. Like, my kids going to want to go in and check it out. You can't buy this, but yeah, you can play. I mean, I'm not going to be getting this for my kids. I don't think most people can afford it. It's probably going to be mostly for developers. But okay, another question. This has come to my mind about the video you didn't show. People talk about it online, but I still haven't really gotten a good explanation about it. You know, when the person, the one in the airplane, right? So I'm sure if they're trying to just show that you can watch a movie with the damn thing in the plane.
Well, there's
which we imagine it done for years, but like, look, are they trying to show you're getting experience of being outside the plane? I don't understand what they were trying to show. Like, you're tripping on the plane, like.
Yeah, well, there's and why am I blanking on the name? Because it's a like Scandinavian airline, KLM for years and years and years had a great immersive lab. And I don't know if they still do, but I know that forever it was like, they were just like setting the standard. And I remember talking to the guy who was running at the time, and he's like, actually, VR is great on a plane, like if the tracking's right. And in fact, even if there were like things are happening on the plane that you're so loose in VR that you like don't get hurt as much. Like there's like weird things that are pretty amazing, but he was doing it much more for like training of flight attendants, you know, and training for what goes wrong. But it is something where, in theory, you know, if they wanted to do a deal with Delta or whatever, that they could say, here during the flight, you get to have your headset. Because are we really gonna, are we like, we have a hard enough time with Wi-Fi, like unless you're like downloading things on a 2-hour long battery plus another thing in your pocket. I think this is a vision of the future example, not necessarily a current application.
We're coming
but who
close
knows?
to
You could
time.
be working, right? Your avatar, you're working remotely. I don't know. It
We're
was
coming close to time. We have a few
Oh,
more
sorry.
questions, Barry. If you want to like ask some more, just try to get through some of these questions.
Okay,
Sorry
yeah, well,
about
first
the-
I will clarify that
Yeah.
Greg was not saying about driving while doing it. He means the feeling, you know, so I think it's more of like the human factors effect, like how will you feel? Will you be disoriented? Will you feel dizzy after you use it? So like I also saw some talk about that online about, you know, will you be disoriented? Will you have an upset stomach? Like, have they done any research in that, you know? So like, so you'll be able to drive your car to work or to a play date or whatever.
I mean, most of that kind of feeling tends to be with bad VR and you know, sort of headsets and lagging of the technology from like your movement, and like eye movement versus the graphics and your body movement versus graphics, and all of this promises it won't happen by the quality of it. But can I tell you? No. I mean, I get the impression that there aren't that many people who have actually put it on. So we will find out what goes wrong. But I don't think that sort of motion sickness that goes along with VR is going to be something that would be something that would happen right away, as it did with early VR headsets being so slow.
Yeah, awesome, cool. All right, well, thank you again for all your time. I let you go through your whole presentation. Thanks for rocking it out. And yes, until we meet again.
Yep. And if anybody wants to reach out, I'm on LinkedIn. I have my website with the Samantha G. Wolfe and all that. Yeah.
Is it
So
okay, Samantha, if we share your LinkedIn on the chat?
yeah, totally go for it. I'm glad that you enjoyed whatever my pretend YouTube title will be. I am nothing if not enthusiastic.
That was great. It was
Love it.
It's always great having you here.
Thank you for having me.
Cool. I put your LinkedIn. That's the best way to reach you, or should I add your email as well? LinkedIn's good. All right, cool.
Yeah. I mean, email's fine too. It's either one. I tend to get more like, let me help you with your marketing messages on LinkedIn than anything else. And I'm like, really? No. I do marketing and branding, and you're selling me the services that I already do. So.
Thank you for joining, and hope to see you next month. So that's really cool. Awesome. Thanks, Samantha. Cool. Next up, we have really nice talk. Thank you, Samantha, and for that overview. It was great. Next up, we have Nils Weinstock, the founder and CEO of Solid Corp, a company based upon breakthroughs in optics. He's the inventor of solid stereo vision correction for macular degeneration. Prior to Solid, Nils was chief business officer at PLLX3. I hope I said that right. A venture created to commercialize 3D technology expertise residing in the physical effects productions business of Lucasfilm. Nils has also been a magazine editor and written numerous articles in technology and media fields. He has also authored 2 books in this field: Design Automation Review and Computer Animation. Nils earned his Bachelor of Science Engineering from Northwestern University, and he's also the inventor of 11 issued U.S. patents and 7 other U.S. patent applications in process. Thank you, Neil, for being with us tonight.
You left off all the interesting thing I've done, but whatever, we'll leave that off. Okay, let me see if I can share my screen here.
Another native New Yorker. Awesome. Cool.
I am not a native New York.
Oh, not native New Yorker? Okay.
No,
Well, you live in New York.
I live in New York. I'm from Chicago. Okay. We have figured out how to correct vision for macular degeneration. And we've also figured out how to do adaptive optics for a few other eye conditions, and to use our technology to do optical coherence tomography and look into the eye and understand what's going on in terms of vision health and brain health going forward. But what I'm going to describe here is just the core technology that we're using for macular degeneration correction. And we have what we think is a gigantic market. There are 200 million people in the world who suffer from macular degeneration, growing rapidly with the aging of society to about 400 million people by 2040. And that's a lot of people. That's a huge part of the AR market. And right now, there actually, as I understand it, the AR market is worth about maybe $3 billion. $500 million of that is AR devices that are low vision aids, doing some digital image magnification and a few other tricks for people who have macular degeneration. And we go way beyond that to actually give them sight in the areas of the retina where they do not have sight now. So how do we do that? Well, we started out to do a more effective, a superior form of AR and VR, near eye displays. We started from first principles. That is, my inventing partner and I, my wonderful inventing partner is Rich Muller, who is an emeritus professor now of physics at Berkeley. And Rich is a MacArthur winner and a lot of other awards in his career, invented a lot of great stuff. And we have a lot of fun inventing this together. We began from first principles, and we decided what we wanted to do was a light field display that would use Stanhope lenses. What does that stuff mean? Well, this presentation talks about the benefits and a lot of other text, and you can, I think, have a link to this presentation. I've uploaded it for Barry and Andrew. So I hope that those who are interested will look at that. But it gives a whole lot of benefits for near eye displays. No vergence accommodation disparity, a display that's always in focus, no matter what your visual acuity is, whether you might have myopia or farsightedness of various kinds. There's a super wide field of view. There's super wide eye box and eye relief. We go way beyond the optics capabilities of the kind of system that looks very nice, I'm sure, that Apple is using and Oculus, a lot of other people. We do that with what essentially is a thinner, lighter weight, easier thing to wear around for hours and hours. So what are we doing exactly? Let me start out here. All right, so we have all these opportunities for what we can do. So here's the core way that we work. Each Stanhope lens gives you an image at infinity in full focus, because it works like a pinhole that if you've ever looked into a pinhole, you know, it seems like you see the world in focus. Around the edges of the pinhole, or a micro lens, if you look through a micro lens, you'll see the image go out of focus. What is actually happening there is that there's chromatic aberration, which appears to the brain like the image going out of focus. And with a micro lens or with any spherical lens, you get a lot of spherical aberration around the edges as well. And with a pinhole, about half of the overall image that you see through the pinhole goes out of focus. So we wanted to optimize the pinhole. Now, the third Earl of Stanhope did that 200 years ago and created what's known as a Stanhope lens. That's just smaller in terms of diameter than the diameter of the human pupil, so that the image presents a parallel ray that passes through the pupil, not acted upon by the focusing mechanism in the eye, the muscles that squeeze the cornea, don't get engaged, and you see a in-focus image on the retina. So we've created a planoptic or light field array of these lenses. And so we get a super wide field of view from all these different lenses, but it means we have to coordinate the multiple images so that they combine properly and the eye sees a single overall image. So you might see this graphic on our website. I haven't updated the website in 4 years. We're just about to do that. It's kept us a little bit out of the radar or under the radar. But now we can talk about specifically where we're aiming what we do. So we created this proof of concept and we started to examine what we had created, and we found out something even more interesting that nobody had ever suspected about what you would get if you had a light field array of Stanhope lenses. Now, let me show you basically what it did. So we started out on our proof of concept with a reference image. You could say you could look through this whole system of lenses at the outside world, but we had a photograph. We used this photograph and we had to print it at the highest possible resolution we could print, which, thank goodness, I developed a lot of photographic products for Kodak in my career. So we got the super highest resolution surveillance film that we could get. We got about, maybe 3 or 4 micron resolution. And the circle describes what's seen through one given lens, say in the center of your field of view. The second circle shows what's seen through the next lens over to the right. All of these circles show how these multiple lenses are actually giving pieces of the overall image that you see, but overlapping. It's not as if they're just showing pieces of that overall image. They're showing a discrete, separate image, which actually projects onto a discrete, separate area of the retina. And that's really what winds up being so important. And it's what we didn't understand at first, and I'll get back to that. But we wanted to optimize our lenses so that we didn't have all that chromatic and spherical aberration around the edges of each of the spheres. So we shaved the spherical lens. We packed it tight with rectangular, but still spherical lenses. And we wind up with an array that's a bunch of rectangles, which is actually pretty easy to make. And we did all of our understanding of what we did through ZMax and modeled out just exactly where we had the aberrations, so that then we could construct software that would adjust the images, turn these pincushion shapes, into more of a square shape by doing some barrel distortion, other kinds of distortions that we entered, so that each image in the image array would interact with the other images and be able to form a overall single image to the eye. And we also needed to create barriers between each of the lenses, so we got rid of some more crosstalk between them. And we wound up with a lens array that looks like this. So now let's talk about what it does for macular degeneration, because that was the huge surprise that we had a few years ago. And then we've been working very hard to prove out, and we actually have proven it out with a number of patients suffering from macular degeneration. So this is a typical appearance of when, you might have, everybody gets a different pattern of macular degeneration, everybody who gets it. Your sight might fuzz out towards one corner or another, but where it's super important is when it fuzzes out in the center of your field of view, because all of us use the fovea, which is, say, the center 5 degrees of your field of vision, to get over 90% of all of the vision that you get, all of the visual acuity. And when that's messed up by having what are called scotomas, which mean that your macula is gone and there's no photoreceptors in that part of the retina, that's when it's truly bothersome and you really can't see. So this is a kind of graphic representation of that, which is not what reality actually looks like. This was a hard thing for me to grasp intellectually because I don't have macular degeneration. But what actually happens is not that you get gray or black areas, obscuring what you're looking at, but you see nothing. You see not even the lack of an image. There's just no image at all. So you may think you're seeing a full image if you have macular degeneration, and then you might put your hand out to a certain area that you think something exists in, and it just disappears in the middle of your field of view. Now, what we present, here's 9 images shown by our prototype. So we're showing 9 separate images, which are conformed so that they appear overall to the eye as a single image. And they appear in full focus at infinity. So there's no vergence accommodation. It's thin and lightweight and all these other benefits. And we started to think, how can we do a good AR device with this? And we thought, well, let's get rid of the central image and let's see what happens if we pass natural light through the center. And I was shocked because what happened was I didn't even see the black spot. We just saw this. Whether you show the black spot or you show a central image, you see the full image just like normal. Now, why the heck did that work? I'm going ahead too much. It worked because we discovered something about the visual cortex of the brain. These 9 images, put together by the brain into a single overall image in exactly the same way that when normally healthy people view something with their 2 eyes, stereo vision works to give you a single overall image. So stereo vision works for each individual eye, just like it works for 2 eyes. It's like we still have some capabilities that existed in our DNA from the time that we were insects with compound eyes. That's kind of weird, and nobody ever thought of that before. But what happens is the multiple images, discrete, in focus, totally separate from each other, are conformed by the brain into a single overall image. So if you have macular degeneration or some other eye condition that blots out the image in some section of the retina, it gets filled in by the images from these other sections of the retina. So the most important place for us to send the image from is from the far periphery of your field of view. And this is a representation of where we think our glasses are likely to go to in a couple of years. So we're going to market actually next year with a simplified version of this kind of thing. It'll be clear view through maybe a corrective lens if you're myopic or if you're farsighted, but could be just a blank piece of glass, could be a sunglass if people have other eye conditions that are strongly affected by too much light coming in. And each of these, I don't know if you can see my cursor, but each of these tiles here is one of our lens tiles with an image in back of it. We'll start out in our first product next year with about 6 to 8 of these, depending on how much information we can process with the processors that we're going to be using. We're working with Qualcomm on that. So we have probably sensors located here, here, and here, looking into the eye. And I haven't talked about what we're able to do with the same exact kind of planoptic array on top of image sensors, but just as the image projected through the lens from a display is in focus at infinity, so what we capture going into a sensor is in focus at infinity, and we're able to get really accurate in focus images to multiple positions on a single sensor through these multiple lens tiles. So we can triangulate from multiple positions, and we can do our patented kind of oversampling and get a really, really fine detail, accurate representation of what's going on the retina and behind the retina. So we're going to be able to do a much more accurate kind of gaze tracking than people are typically able to do now. I could point you to some research papers that talk about why this is going to be more accurate. And talk about, in the previous presentation, people ever wearing AR glasses while driving. Well, that's what a lot of our patients, customers are going to want to do, because if there's one thing that is really disabling about life in America, it's when you start to lose your vision, but you still want to be able to be independent and drive when you're 70 or so years old. So yes, people are going to wear this while driving, and we're going to be able to do gaze tracking and object tracking fast enough, and passing through the information from cameras looking at the outside world fast enough, so we can have augmented information coming to the eye from these displays on the periphery of the field of vision, overlapping what people are actually looking out at the world. And it should happen fast enough so that there's not too much of a lag, and you're actually able to see through and do things like drive through it. Now, as I understand it right now, Apple claims a 12 millisecond lag from the cameras looking out at the world to the representation through the displays that they're showing. And that's almost good enough to not be noticed. Saccade movement, the very, very quick, hard to predict movement of your eyes constantly jumping around, is about 5 milliseconds. That's what we have to get down to be able to do this, so that you can drive, so that you can feel comfortable wearing these things for hours at a time. And I feel very strongly, I have run the numbers, we're going to be able to be sub 5 milliseconds doing this. And eventually Apple and others are going to be sub 5 milliseconds too, in terms of following saccade movement. But I think we'll get there faster, and we'll be very accurate with our system of doing it. So we had to do a lot with software to be able to adjust these multiple images so that they all work together. And we've already done this in a prototype. We've been testing that prototype at Lighthouse Guild here in New York, which is, as I understand it, the largest nonprofit for serving people who have vision disabilities. And we've actually proven, showing test charts of various kinds of tests for macular degeneration, that people actually get vision in sections of their field of view that they have not had vision in before. So we're pretty excited about being able to do this. And I think that's my presentation. If you got any questions, I'd be happy to answer them.
Wow, that's pretty amazing stuff. I mean, it's mostly beyond me, although I did study some neuroscience in college, but about peripheral vision, fascinating stuff. So yeah, I think we need some ophthalmologists and neuroscientists to really understand this clearly, but it really seems like you're onto something very big here. But Nils had a question about stereoscopic vision. I mean,
Nils,
my
you want to ask
understanding.
that? You want to, since you have access, so feel free.
Yeah, Neil, this was absolutely riveting. And somewhere towards 2/3 through your talk, you mentioned this realization you had about how the optic nerve works, and how there's something akin to stereoscopic vision even out of one eye. I didn't quite catch it. I would love to hear it again, because it just scrambled my brain.
You know, actually, I did a lot of work in 3D. I helped to found a company called Expand Cinema that was #2 in the world in 3D in the cinema. I hadn't worked in 3D before that, but also did some work afterwards. You heard him talk about me working with Lucasfilm. We were doing an auto stereo 3D display. And one of the things that one of the really brilliant guys in understanding the nervous system dealing with 3D, a professor at Berkeley named Marty Banks, told us early on when we started working at Solid was so much of our sense of 3D is created by saccade movement. Now we have 2-eye 3D, right? Well, that's what we normally think of. That's what we did with glasses when I was at Expand Cinema, that you know, we had one view in one eye, one view in another eye. But natural normal 3D is not only dependent on your 2 eyes. So saccade movement, your eye is constantly jumping a little bit here, a little bit there, a little bit there, and it's constructing multiple angles of view on the same object. So understanding saccade movement gave me a hunch that we actually could construct this solid image, and that's the name of our company, Solid, because the word stereo is Greek for solid. We could construct this stereo view from the multiple angles at which you're seeing these discrete images in the single eye. I hope that begins to explain it.
Nice. Barry, do you have any other questions you want to ask? And thank you for that question, Nils, and nice answer.
Yeah, I was going to post some questions for post the document, the presentation that you just did. But I'm just curious. So you said you're working with Qualcomm so I guess on the actual these like she's basically to make it on a chip and then to put this array around whatever the form factor is, like you showed glasses or something. You're working with them to build this out, or?
So Qualcomm supplies the processors. They're running about 90% of the AR glasses in the world, as I understand it. I think the only major AR glass company that is not using Qualcomm chip is Magic Leap. It was also not using Qualcomm at the heart. They're using their M2 processor. You know, it's really important to me to work with what's quasi standard, because you know, we've got the support of a company that's doing it for, you know, 100 other AR glasses as well. So you know, obviously we start with relatively low quantity. You know, you do what you can with the first rev of a product. We think we can get to really high unit volume because, after all, there's hundreds of millions of people who need it. To be able to bring the price down, whatever. So there's a Snapdragon chipset that's in most of the AR glasses that are out there. And we're going to use the same chipset.
Very nice. Cool. Yeah, well, we wish you the best of luck with that. And I guess you don't have a demonstrator currently with this, right? I mean, you have patents on this technology, but it doesn't seem like you have I mean, I guess a proof of concept, nothing that maybe we can show, but if you do.
Yeah, we have a monocular prototype. So just you look into it with one eye at a time, and it's running on a desktop computer. And we're in the process of doing a prototype based on the Snapdragon that'll be out in a few months. And so, of course, when we get that, I'd love to show it to the group as well.
Very good. Okay, we had one other question, and we have to go on. Just your opinion. When do you think that we will have consumer AR glasses?
Our technology, consumer, next year.
Okay.
By
Nice.
consumer, though, I mean people with vision problems. This is a corrective vision device. You know, eventually, I think there's a lot of opportunity to do it for a lot of other applications, but I'm really focused on corrective vision. You know, my father was a great baseball player. He had what's called hypervisual acuity. He could see the threads on a baseball at 60 feet away coming out of the pitcher's hand.
Wow.
And then he went blind from well, he went blind from glaucoma, which we can't do anything about. But it got me thinking about visual aids. So we can't help glaucoma, too late to help my dad, but we can do this for people with MD.
Amazing. Cool. Well, keep us posted. We'd love to hear what your new updates on this stuff. Great. Thank you so much.
Compelling work. Amazing. And you've received a lot of wows from the audience, so it's a really neat project. And I'm
let me just say,
Yeah.
we're looking for coders, especially if people know XR. We need to,
Okay.
we've been
Oh,
writing
so
OpenGL. We need to
Nice.
redo things in OpenXR. If you know OpenXR, get in touch with me.
Oh, so put your contact information and yeah, we'll put it out there for you and your LinkedIn, whatever. Thank you so much again.
That's really cool. Yeah, appreciate it. Awesome. So Nils Pihl is here with us, a leader in the space, and he's a Swedish entrepreneur, behavioral engineer, and social transhumanist, specializing in the intersection of modern technology and human behavior. Based in Hong Kong, Nils is leading Auki Lab's effort to build a collaborative spatial computing protocol to allow for shared AR experiences. I'm really excited to hear more about it. Thank you, Nils, for spending time with us today.
Hey, Andy, thank you for having me. Good morning, everyone from Hong Kong, from where it's technically the future already. It's a Thursday morning here. The future is looking bright. These previous two talks have just been absolutely riveting, and there's so much I want to talk about now. And I think I'd like to jump off of the question, like, when will we see consumer AR glasses? And I'm going to throw a contrarian take into this and say that Apple has not really moved the needle on consumer AR glasses. The whole industry is looking the wrong direction. We're not waiting for a smaller, better headset. We're waiting for something much more fundamental. We're waiting for the ability to have shared AR experiences. Let me explain. Today, digital devices like your phone or your glasses have a very, very poor understanding of where they are in space. You have a GPS, sure, but my GPS barely knows I'm in this building. It certainly doesn't know I'm on the 28th floor, and it doesn't know the difference between being here and being here. And this poses a challenge because two devices here and here that want to manifest a digital object in the same physical space are going to really struggle to do that. And if you've ever tried to set up any kind of shared AR experience where people really see things in the same place, then you have almost certainly played around with spatial anchors or digital twins or something like this, where essentially the way you position the devices is you compare the camera feeds to the two devices. That's essentially what it is. You create a 3D representation of the area you want to operate in, and then you try to compare each camera feed to the 3D representation of the area you want to be in. So if, for example, if you wanted to have a shared AR experience in Pokemon Go, it takes about a minute to set that up. You have to scan a QR code on the other person's device. You have to stand next to each other, shoulder to shoulder. You have to point your phones at an object together, and then you have to start walking around the object slowly in the same direction. You have to do this for a while. Please bear with me. And then we are calibrated into the session. And now you decide that you want to join me and Andy in looking at this Pokemon, but that means Andy and I are going to have to start over because everyone has to do this calibration at the same time, right? So positioning is incredibly, incredibly difficult. And what this means is that almost nobody has ever had a shared AR experience where two people really look at something at the same time. And I think that's what's missing. In fact, here's my controversial claim. If there was a pair of AR glasses out now that could only render text, black and white text, can't render a Pokemon, can't render a color image, can't render a 3D asset, it can only render text, but it can render the text in the same location for everybody, people would use those. because what shared augmented reality allows us to do is to communicate at a much higher bandwidth. Information has context. It's kind of like, context is kind of like the compression algorithms that we use to communicate with each other. And when you can put information in its right physical place, you can communicate with me a lot faster. Just to have a little frivolous example here, if Andy and I are at a party and some blowhard is just talking, but Andy finds out that this guy's fly is open, the ability for him to just show me in space, a little text note, look at this fucker's fly is open, right? And I know who we're talking about. I know where the information is. Imagine how much it would take to communicate that precisely. Or imagine you're in a city like Hong Kong, like I am, and you're star-crossed lovers across two different buildings, and you're trying to figure out in which window are you? It's like, no, I'm right here. And then you can see, oh, do you see that thing happening down there? Imagine being able to point in 3D really, really accurately. Communication is what shared augmented reality is really for. And I'm going to make another little bit of a controversial claim. Augmented reality is the longest running human technology project there is. Humanity has been working on AR longer than anything else, because it turns out language itself is augmented reality. Let me explain, right? So if we were to imagine that we were walking through a forest together, right? And we came across a fallen tree. And I point at that fallen tree and I say, hey guys, look at that beautiful couch. The moment I have said couch, something happens to your perception of the scene. You now see the sittingness of the tree if you didn't see it before. I've annotated your perception with additional context and meaning. This is what language is for. Language is for manifesting your knowledge and imagination in the minds of other people. Language is for manifesting your knowledge and imagination in the minds of other people. And this is what augmented reality allows us to do in theory, at least when it's shared, at a much greater bandwidth than anything that has come before, And the only thing that will ever beat it is a direct neural interface. Shared augmented reality is the second to final train stop on this line, right? The direct neural interface, that's the final station. And shared augmented reality is the next to final station. And we are so close. The killer app for AR is the ability to be able to communicate with each other. I think right now, AR glasses are suffering. They're very big because they require a lot of compute. They drain a lot of battery because they're processing like really big images, and they have to render all of these 3D objects. Who gives a shit, right? Like all of the app examples that Apple showed us, first of all, they never once showed a shared AR example in the Vision Pro, in the Vision Pro announcement. Not a single frame of two people wearing Vision Pros together. Even though they partner with Disney, the pro vision here is clearly we're going to watch Disney alone, right? As you do. Kind of sad, right? What's missing is the ability to have shared augmented reality. And as Andy helpfully said in my intro, we're working on a protocol for collaborative spatial computing, meaning we allow the devices to understand space in real time together so that they can manifest information in space. So yeah, that's my contrarian claim about the AR glasses. They will become consumer when they stop trying so hard to like render amazing 3D things and instead focus on what it is we will really use them for, to communicate with each other. I've had long conversations with the guys at Qualcomm, etc., about this. Stop with the 3D and the expensive, just like, let's make a pair of glasses together that just renders text. because I have huge international retailers that would use them immediately for their staff, right? Just the ability to be able to show staff members where things are supposed to be in the store, just a text label like this is where the sugar goes, would save, for someone like Walmart, that saves them tens, if not hundreds of millions of dollars of productivity every year. They'll buy those glasses. What's missing is the ability to anchor position in an intersubjective way in space. And in the spirit of the very interesting presentation that Neil just gave, I want to talk a little bit about why it is almost at a neurological level we need this. Like, why do we have this drive to have shared experiences? And I want to talk a little bit about sensory congruence. Let's start there. So as humans, at least, but possibly even as biological beings, but at least as humans, a part of our experience being alive is that our body, our brain, our mind tries very hard to achieve sensory congruence. We want to make sure that the things that we see, that we hear, that we touch, all match with each other. And whenever our senses don't agree with each other, it becomes jarring and actually uncomfortable. If you have a VLC or some video player like this on your laptop, you can try to see what happens if you desync the audio with the video. Try to desync the audio, even by just a little bit, and notice how that feels in the body when the audio and the vision don't match up anymore. The need for sensory congruence is so deep that we even need external or social sensory congruence, right? I don't know why I'm typing this down, but we also need external sensory congruence. We need external sensory congruence. What does that mean? It means that when other people don't perceive what we perceive, that also feels weird. If you are the only person to not laugh at a joke, what does that feel like? If you're the only person that heard that cry for help, what does that feel like? We need external sensory congruence. We need external sensory congruence. And the reason why AR is trapped as a gimmick right now is because no one wants to return to AR because it actually feels uncomfortable to be the only person able to see the thing. It's not nice to be the only person that is able to see the thing. It messes with our very core of how we want to perceive the world, how our body is at rest with our sensory inputs, and also how we are socially at rest with the rest of the tribe. A bit of a mushroom-inspired psychedelic insight is that an inside joke, what is that? An inside joke is proof of past intersubjectivity. It's proof that you previously had a moment of external sensory congruence. That's what an inside joke is. An inside joke is a way for you to demonstrate to each other that, hey, I was there. So we say that Auki Labs is ultimately like, what is our purpose? What are we here to do? We are here to bring about shared understanding, or intersubjectivity is the big word that we like to use. Our CRO doesn't like when I use this word intersubjectivity. It's too nerdy, but shared understanding, right? We're trying to bring about shared understanding to allow people to manifest their knowledge and imagination in the minds of others. And the way we're going about doing that is through the medium of shared AR. That's what we're betting on, right? We're betting on the medium of shared AR. And to do that, of course, we have to solve positioning. I've completely lost track of how I'm doing on time. Yeah, how am I on time?
You have 3 more minutes left to talk if you like.
3 more minutes. Okay, then with those 3 more minutes, I think I want to show you what I'm talking about. Now, please excuse me that I'm opening up one of my decks. I don't want you to feel like I'm pitching you, but I kind of want to show you a few demos just to show like how meaningful even just a text label in space can be. So I am gonna going to share my screen. I'll blast through this really, really quickly. I assure you, I'm not trying to sell you anything, but I'm going to open this deck anyhow. Okay, can you see my screen? Fantastic. So this nice peach little logo here with the mana rune, we're Auki. And we say, share your vision, share your vision. Hopefully that makes sense now. We make what we call matterless domains, which is a kind of virtual real estate for shared augmented reality. Virtual real estate for shared augmented reality. We believe that shared augmented reality allows you to, I'm saying it again, manifest your knowledge and imagination in the minds of other people. And that this is something so important, so impactful, that it genuinely represents the next historical leap, not only for human language, but for our ability to understand each other and even the machines that surround us. Augmented reality is a really big deal. Our unique solution is powered by this thing we call the PostMesh, which is our decentralized protocol for collaborative spatial computing. And our vision is that by providing this canvas for shared AR, that the PostMesh will become the foundational protocol, not only for positioning, but for the AR metaverse and even AI and robotics ability to perceive and interact with the physical world on Earth and beyond. Simply put, if we strip all of this down, what is it we do? We're building the AR metaverse from the ground up by providing virtual real estate to commercial real estate. Why would they want it? Let me show you a demo, right? And all the demos I'm going to show you, this is actual footage, no CGI, no bullshit. It looks janky, so you know it's real, right? It looks janky, so you know it's real. And I'm going to play this here. I'm going to turn the audio off and just illustrate. This is our demo space in Hong Kong, a fake grocery store. And a colleague of mine has left a note for me with a shelf that he found that was busted. And he doesn't know how to fix it. So he left a note for me so I can find it and go and fix it. Right? He just left a note. What does this mean? It means he didn't have to go find me. He didn't have to walk me over to the place. He could connect with me asynchronously. Now, as you saw, fixing that shelf was obviously very, very simple. This is clearly a staged thing, but the principle is the same. If I hop on over to the next slide here, maybe. What this allows you to do is like communicate more effectively across time with each other. You can communicate more effectively across time with each other because you can leave information in space where it's supposed to be. And for retailers, this is massive. Like, for example, just to show like how economics really will drive glasses adoption here, or even phones for AR, right? If you are a European retailer like Lidl, you have 13,000 grocery stores. You have 13,000 grocery stores. And if you can speed up the tasks that are inside the grocery store for the people that are on the floor that have to find things, restock, relabel, do these kinds of things by just 5%, right? So instead of something taking 4 minutes to do, it just takes, 3 minutes, 50 seconds. If you can shave off those seconds because people find the issue faster at the scale of one of these retailers, that's worth on the order of hundreds of millions of dollars every year. Hundreds of millions of dollars every year. So I'm out of time. I'm out of time. But yeah, my controversial take is that we are not waiting for smaller headsets. We're not waiting for more realistic graphics. We're just waiting for the ability to use AR to communicate with each other.
That's amazing. I totally agree. I think that was a big miss in Apple pitch of not showing really any interaction with others besides maybe like they kick the ball and your kid is in there and you're sort of interacting with that. But other than that, it was really not social that I noticed in there as well. So yeah, it's really, really strong. Okay, so in great demos, you said you were not going to do a demo, but you did. It was really on. Thank you. So a couple questions for you. Oh, here come the questions. They're rolling up. So is there any input on the use of the AR tech using classrooms? Yeah, like I thought that solar system model, I think that definitely lends to interaction. And my daughter might have some questions too, as a kid.
We have a lot of educators telling us that they want to use this as an educational tool. And I think it's very, very possible to use this as an educational tool. We have a Unity SDK out so that you can start building your own applications for this. You can go to aukilabs.com and click your way through until you find our SDK. You can download it and you can start building shared experiences yourself. One of the things that I think is challenging with education, it's a complete business thing. It's very hard to find the people that will pay for the thing. Like the teachers want this, but who's buying it? Who do you talk to sell it? Like there's an operational complexity there in selling these kinds of educational solutions that I think is holding back the educational space. It makes it very hard for startups that want to make applications for education, because it's a very tricky, long sales cycle. Yeah.
Well, we got Walmart too. So yeah, I know someone who works for the Walmart out of Hoboken over here. So if you want to contact over there, definitely, their lab open in Jersey. So I'm glad to put you in touch with them if you like. She's part of the
Happy to chat.
natural language processing parts, as well as an Amazon. I know an Amazon guy here too. So anyway, I'm glad to put you in touch. Cool. Yeah, but I also mentioned ZSpace on the chat because that's a company I knew when I worked for Merck doing education. But yeah, definitely it's hard. Okay. How easy is it to update the virtual space when the physical space is, I'm not sure if they mean what Nguyen means by modified, but maybe not like a perfectly like rectangular space, or there's a lot of obstacles in there, but maybe Nguyen can clarify that. But yeah, how easy is it to update this virtual space?
I have a suspicion that Nguyen means like what happens if the physical space changes, like if you remodel everything. And yes, Nguyen's question is rooted in like the deep shared trauma of the AR space, that positioning is done with digital twins, right? Positioning is done with digital twins. So if you change the physical space, surely you broke everything, right? Because that's how digital twins work. And we've just internalized this by now. But Nguyen, what we do is so stupidly simple, right? We use QR codes. Each QR code is unique. And then we use AR tech to measure the distance of the QR codes. And each QR code becomes a portal into the space. So if you move the shelf, doesn't matter, the portal still works. If you had some material anchored to that shelf, sure, you're going to have to move that thing unless you are anchoring it with some kind of computer vision. But the coordinate system doesn't break down because you move a shelf. And what's cool with this also is that since we're only doing this with QR codes, you can set up an entire grocery store really in minutes, right? So our demo space is about 1,000 square feet. And when I really want to impress a customer, I will take everything down, right? I'll just like, hey, let's set this up from the beginning together, right? And the only step I don't do is place the QR codes, because like that physical labor, they don't want to see me do that. So we've done the first step, the QR codes are on the ground. Then all we have to do is we walk with our phone from one QR code to the other, just measuring the distance. Now we've set up a coordinate system. Now we can open up one of many, many apps that can connect to this coordinate system and just start placing content. So the fastest demo I've ever done of from having nothing to having 3 different applications running in the virtual real estate. One note-keeping thing for staff, one promotional thing for the shoppers, and a game that the shoppers can play. 10 minutes, right? So from 0 to having 3 different applications running in the space, 10 minutes.
Awesome. We just have time for one more question. I'm just going to ask you really quick, then we have to move on. But as in terms of an object being real or fake, so if someone is experiencing, if 2 people are experiencing an object in their environment shared, does that change how the augmented reality experience is perceived in the brain? Like if someone's viewing an augmented reality experience alone and no one else could see it, does that tell the brain that maybe it's not really there versus the other way around?
So when we use the language of in the brain, I can only say probably, but as a matter of like your consciousness, definitely. Like you can try this for yourself. And we see this all the time, right? Like if you've looked at something on your own, cool. But if two people see it together, like if we're watching an AR dog together, for example, and you see me reach out and touch that dog, right? That does something. And we see when we talk to people in our demo space that they will point towards things, like even once they've put the devices down, they will point in space towards the things that they saw, because it's still there in like their spatial context, right? That thing over there that they saw. And I think this is what shared augmented reality allows you to do. It kind of allows you to paint a physical space with new emotional contexts. Sorry to be a little bit hippy-dippy, but this is really, really powerful. When other people have seen what you see, it feels more real. You can trust that it's there. Reality is that which we perceive together. Like that's what reality is.
Beautiful. Thank you so much, Nils. Very compelling talk. And feel free to post your LinkedIn or email, whatever, however you'd like to be contacted in the chat in case.
Happy to share my LinkedIn. Give me a second. And also, I would love to just share a link with everybody. There's a fantastic, one of my favorite science fiction authors, Alistair Reynolds. You may be familiar with his work if you watch Love, Death, Robots. He wrote 2 of the episodes, Sima Blue and Beyond the Aquila Rift. He recently wrote a short story that's on our blog about why we need to be careful about visual positioning. Like why we need to be careful about letting companies like Google, like Niantic, etc., actually position our devices by looking through the camera. You should definitely read this story. It's super riveting, and it gives you a lot to think about for the future of AR, because the future of AR is not necessarily just positive. I'm going to pull up my LinkedIn here and share. Actually, I think I know the link by heart. It's just linkedin.com/in/my name, like so. That's me on LinkedIn. I see some of you have reached out already. Happy to connect.
Awesome. Thank you, Nils. Really good having you here. Nice talk.
Thank you for having me. It's been a pleasure.
Amazing. Thank you. Next up, I'm excited to introduce Christopher Grayson, Creative Director, Marketing Consultant, and veteran of the New York advertising industry. He has produced market research on the AR/VR industry, and in particular, the near-eye optics component space for about a decade, and writing in this niche has been a contributing editor to such publications as Upload VR and 2020 Magazine, the leading trade publication to the optician industry. He sporadically publishes at his blog, giganti.co. I hope I pronounced that right. I apologize if I didn't. And has sold market research to tech companies and eyewear companies, both large and small. It's good to have you back here, Chris. Thank you for joining.
I had to unmute myself. Thank you. Thank you for the intro. Let me get this share screen set up here. Okay. I'm also going to I also have a vision for what will succeed in the consumer space. I don't think it contradicts anything Nils was saying, but it's on a different vector, if you will. Consumer viable form factor. This is what I really care about. And what do I mean? I only care about those specific advances in smart glasses that will achieve a form factor that is viable for all-day wear. A consumer device. And by consumer viable, I mean by the sensibilities of someone who isn't an engineer, someone who doesn't work in tech. And I think some of you probably know what I mean by that. Consumer viable is a sort of minimum requirement for mass market adoption. One question, I think probably everyone here is encountered, and I certainly hear it often. People want to ask, do I think, Google or Microsoft or now, Apple or some other startup is going to sort of like win the consumer market? And I think that question is even kind of a misunderstanding of the marketplace. Consumers are not generally going to debate whether they're going to adopt one of these tech brands or another. The fact is, the consumers are going to debate whether they're going to adopt smart glasses at all versus their existing corrective vision eyewear or sunglasses. So far they've chosen, say, this is actually a Warby Parker ad, Exotica, or Marchand, Marcolin, Sphilo, all the sort of major eyewear manufacturers. So what I started kind of narrowing my interest down to was, who are those component suppliers, manufacturers that are making things that are going to get us to something that is, frankly, the low-hanging fruit is going to be people that already wear glasses. If you already wear glasses, you're going to be more likely to buy smart glasses. It's just a matter of the requirement has got to be that they first and foremost function as glasses. And so one of the first things I looked at was who was getting corrective vision, who was getting a waveguide into a prescription lens. In 2019, writing as a guest editor for Upload VR, I revealed a patent that was held by North. It was actually filed in the name of Thalamic Labs, what they were incorporated as at the time. And it was about getting a waveguide into a prescription lens. And in that article, I also interviewed Interglass, a company out of Switzerland, and Digilens. What was not revealed in that particular article was that, I think I can say this now, Interglass doesn't exist anymore. And I facilitated an introduction 2 years before in 2017 between those two companies, Digilens and Interglass, that led to R&D. Interglass is interesting. They had come out of Federal Institute of Technology of Lausanne, along with two other kind of sister companies, Lim Optics, which made MEMS, sort of mechanical actuators for a LBS illumination. So another company was Composite Light Labs, which actually made LBS device. So these three companies have kind of worked together, and I was curious at the time why the second two, Lim Optics and Composite Light Labs, were acquired by Intel some time ago, 2015. I would later learn, not too long ago actually, that they were acquired for Vaunt. But I learned later that Hans Moritz was the guy who actually negotiated that deal, and he just said they already had another combiner, so they didn't really need Interglass. And in 2018, Intel just sold off everything related to their wearable tech, and this had nothing to do with their wearable tech group. It was actually because Brian Krasnick, their CEO, had an extramarital affair or some kind of sexual affair with a employee, and had to resign. And another fellow, Robert Swan, took over as CEO. He's the CFO, and he had to reorganize the company. So Stephen Lake of North ended up buying their patent portfolio. And I'm giving him sort of some business context, these things. So Lake bought that IP portfolio, and when COVID started, North was trying to raise a round and they couldn't raise money. And so he sold off that IP, that patent portfolio of to metamaterial. Eventually ended up exiting to Google, for those who aren't aware. So the thing that makes sort of all of that backstory a little bit interesting, particularly to me, is that Jonathan Waldron of DigiLens ended up going over to metamaterial, where he's now the CTO, and they acquired Interglass, and they now manufacture a waveguide inside of a prescription lens, which is sort of my, what you might say, informal role in the industry, where I look for these technologies and make introductions, and that sort of was kind of at least partially a result of me kind of trying to push the industry in a given direction. There were competitors in that space. Again, backstory: Wave Optics worked with LuxXL, 3D printed lenses. Wave Optics ended up getting acquired by Snap. LuxXL very recently in December was acquired by Meta, by Facebook, after sort of replacing Wave Optics with Loomis as their partner. And so one of those hurdles that I considered sort of one of the most important, one of those hurdles was cleared. So from there, getting to a consumer viable form factor, I'm going to look at the temple. And this is where everything has to hide. This is a pair of Oakley sunglasses. But if you look at really any smart glasses out there, they will, of course, be photographed for the purpose of marketing for the most admirable, most attractive direction, front on, or a way that kind of hides how thick the temples are, that makes them really not so much like a normal pair of glasses. And the bulk there at the temple is largely a result of collimation optics. And so you have whatever your light engine is. It could be, LBS, could be OLED, or in this case, I'm going to talk about micro LED. And so it was, how do you miniaturize that optics? Now, Carl Zeiss has this subsidiary, TUS, and they make some smart glasses, and they were kind of one of the first that they actually integrated the collimation optics. And let me explain what that means. Probably should have had an illustration of that in a slide. When light comes out of most forms of light engines, particularly LBS, where the laser is scanning back and forth, so it's always coming at a different angle, but also with even like a micro LED or anything kind of panel-based light source, you need all of the light traveling in the same direction to enter the input coupler of the waveguide to move the light in front of the eye. And that's sort of a primary contributor to the bulk that you see when you look there at the temples. And so even though Carl Zeiss incorporated this into their lens, it's still pretty damn bulky. We're still not getting to a consumer iframes form factor just yet. And so this had kind of been the focus of, once we had prescription lens, what's the next thing? So I've been focusing a lot on this area. What goes into the temple? Collimation optics are bulky. How is that going to be solved? And so I actually demoed these a couple of weeks ago at AWE. They're bulky, just as you see here. And so one company I was kind of looking at was Metalens. I had been an attendee at a meetup somewhat similar to this, and had seen somebody pitching from Metalens in that meetup. And the claim, now what they actually do is they make these, they're a metamaterials company, and they make metal-based lenses that are very flat. And so for a time, I thought they might perhaps be a solution. They ended up having, my contact there ended up turning over 3 times. They had a lot of turnover. I might want to mention they were spun out of Harvard University's material sciences department. So when I was meeting with somebody else, another engineer in the space, so basically explained to me that while they may have made this claim in a presentation, having outreached them several times, they really weren't giving me information to back that up. And so another optics engineer basically said that they were sort of like making claims outside of realistically what their technology could do, that that yes, in theory, they could flatten collimation optics, but the type of technology they were using would diminish the light source substantially. So it wasn't really, so that one turned out to be a dead end. It wasn't really a solution. Something that looked promising in the past is Plessy, which if you're familiar with them, you would perhaps know that they were acquired a few years ago by Facebook, and then I shouldn't say they were acquired. They actually were not acquired. They entered into an exclusive buyer relationship where they can't sell to anyone else, and Facebook will basically acquire all of the inventory that they produce. But they had licensed from Cambridge University, they had licensed this gallium nitride on silicon backplane technology that was supposed to have a natural collimation effect, where light that was coming off of the micro LED would all move in the same direction in unison, and would eliminate the need for collimation optics, which could make the optics module substantially smaller. But then, as I say, shortly after that, they entered this relationship with Facebook, and they were actually the supplier for a few other companies. And so those companies had to in turn find other suppliers. One of those was Vuzix. And so they ended up going with Jadebird. And Jadebird is a Chinese company that's also using a gallium nitride on silicon backplane. And the problem with that technology was that even though they had the collimated light, they couldn't do RGB. So they could only do monochrome. So they could do monochrome red, green, and blue. And so Vuzix and Jadebird, they did a collaboration where they used a thing called dichroic X cube, where they put, so this is showing if you shine white light into one side of this so very specialized type of prism, that it separates into red, green, and blue out of the 3 other sides. Well, so they did this in reverse, and they put 3 micro LEDs on the 3 sides of the X cube. And so they combine, and they're RGB when they come out the other side. But if the goal is to reduce the size of the temple, then they've defeated their purpose, because now you're back to a bulky temple again. So what all of this is really leading up to is this one company, Porotech. Porotech was actually spun out of Cambridge University in the department with many of the same people that developed gallium nitride on silicon backplane that Plessy is using and is licensing from Cambridge. So this spin out earlier this year, they unveiled that they had now achieved full RGB in a single panel at a micro display scale. And so what they have now is a couple of different technologies here all coming together, a thing called dynamic pixel tuning, which is also gallium nitride based. And I'm going to be candid with you. How this exactly works is, shall we say, a little beyond my pay grade. I'm still sort of poring over a lot of the literature on this, but the ultimate end goal of it is that they've truly done something that nobody else has done with with a micro LED diode. Is that they've been able to, normally you would cluster either adjacent or stacked on top of each other. Hello? Oh, that was weird. Stacked on top of each other, red, green, and blue diodes. And so what they've done is they've been able to tune the diode where the same diode can be red or green or blue, depending on the current that's being sent to it. So they were able to substantially reduce the size of the micro LED while also reducing the energy consumption. But for my purposes, the other real breakthrough is that using nano optics, they were able to put a collimation lens directly in front of each pixel. So they've completely flattened it. So what this means is that their micro LED can be placed flush against the input coupler of a waveguide and effectively completely eliminate this giant piece of bulk right here at the temple. So that's when I attended, I don't know how many people here attended Augmented World Expo, but 2 weeks ago I was out in Santa Clara, and this was sort of the highlight of, they didn't have a giant booth or anything. They weren't, one of these big, huge companies, this small little Vortec, but going to their booth and seeing the demo, they pulled it off. So while it's a company that most people in the space have never heard of, I think they're doing some of the most important work right now in terms of what will get us a pair of smart glasses that gets closest to being the form factor of a consumer viable form factor for eyewear. That is the conclusion.
Amazing. Thank you so much, Chris, for joining. If you have any questions, feel free to post in the chat. Cool. So do large sunglass manufacturers have a bigger advantage than the technology companies?
I'm sorry, could you say that again?
Do sunglass manufacturers have a bigger advantage than the technology companies making the optics?
Yeah, I think that this is yet to be seen. I mean, what the tech industry has is very deep pockets. Like that's the bottom line. I know people in the Italian iframes industry, and many of those companies, obviously Luxottica, have for their industry substantial research and development departments. And some of them, sort of Luxottica being the sort of elephant in the room, have just astounding market share globally in general, but also in the US specifically. And at my blog, Giganti.co, you can read a ton about the Italian iframes industry and kind of how that industry is structured and how they've intersected with the tech industry and whatnot. But they don't, to say that they're a gargantuan company within their industry is nothing compared to the size of Silicon Valley tech companies. And for look at, I mean, even Amazon is in the space, and you've got the size of the Intels and Microsofts and the Apples and the Googles. They're in Facebook, Meta, they have such deep pockets that the iframe companies have to really pick and choose very, very carefully where they make investments, because they don't have as much money to gamble with. It's that simple. But what they do have is they have brands, they have an existing market, they have the sales channels, and I think that if you look at how the tech industry has not really been able to successfully make inroads into this space, that most of those companies see themselves eventually partnering with big tech companies. And from their business model standpoint, I know that's how I talk to enough of them to know that that's kind of how they look at it. They expect that they will, that they will end up being brand partners with large tech companies, and that they will handle a lot of the kind of business side and sales channel and everything like that. But if you I wear glasses. Okay, if you are already somebody who spends a few $100s on prescription iframes anyway, you're the low-hanging fruit. But the catch is the smart glasses have got to first and foremost be good at being glasses, and that means both from a functional standpoint. You've got to be able to have people's prescriptions, and they've got to have the vision correction. It also means from sort of an aesthetic point of view, like your people spend a lot of time picking out glasses, and the glasses you put on your face, in many ways, kind of become your face. You can completely change the sort of aesthetic look of somebody's face depending on what glasses they're wearing. And and people want a certain level of individuality, and people have different shape faces, and people have different aesthetics. And before you're ever going to have something that's the all-day wear smart glass, you have to be able to address those things that the existing iframes industry already addresses. That's just sort of going to be table stakes.
Awesome. Thank you, Chris. Another question for you. Which company do you think will launch an eyeglasses type form factor with true AR functionality? And will it be an eyewear company?
I don't. It's very, very close to that question. Is Google or Apple or I don't. That's kind of not the way I look at it. I don't. Let me back up. I'm going to answer a different question, but it'll put that one in context. Okay. This is a humorous anecdote. Okay. Do you know who Noah Zirkin is?
Sure.
Good. Okay. Noah, back in 2010, I love telling this story, and told 100 times, but back in 2010, he was at the inaugural AWE. He was speaking in the Q&A afterwards. He was asked, when do you think consumer smart glasses are going to be available in the market? And he said that he had stopped answering that question. And he said, because if he had to answer it honestly, he said, he would say it feels like it's about 3 years away. But he said, if you asked me that 3 years ago, I would have said it's 3 years away. Okay. And this is, it's a humorous anecdote, because if you start looking at like the leaks of about Apple entering the market, you know, the big leak at Bloomberg came out in 2017. And the leak was that they were preparing for a launch in 2020. Okay. And then in 2020, they pushed that back to 2023. Okay. Now it's 2023 and they released a headset, but they haven't released glasses. And the rumor is that their glasses will be 2026. So it's a painful thing to speculate. If you've been in this industry for a while, I mean, I think it could be from an iFrames company. It could be from a tech company. It could be from a startup that we haven't heard of yet. But the fact is, as I track these technologies, we're getting pretty close to where you'll be able to get a respectable user experience in a consumer viable form factor. And the next step beyond that is going to be, and you know, this could be where Nils comes in, is going to be what use case breaks through. You know, you look at sort of every technology hardware platform needs the proverbial killer app. And so I think before you can answer that question, we're going to have to see what the killer app turns out to be. You know, I have some opinions about use cases that I would like to see, but ultimately it's going to be about what's the killer app use case once the hardware is there. And right now the hardware isn't even there yet.
Awesome. Do you envision like how far in the future do you envision there to be like a few competing brand name headsets in the market?
This might, and when you say headset, do you want, you know, is your expectation that you have, you know, sort of realistic stereoscopic content within your field of view?
Yeah,
like
realistic, wide field of view in a pair like the ones you're wearing.
Disappointingly, I think you're probably looking at least the late 20s. This is not, it's unfortunately, I don't want to sound jaded. I've just been tracking this long enough. Like I said, the whole like always 3 years away thing. Yeah, the cliche, you know, hardware is hard, and Waldron likes to say hardware is hard and optics are harder. It's not. Most of these technologies that relate to the near eye optics, they don't have one of these like hockey stick curves. You know, these aren't, you know, there isn't like a Moore's law of optics. If you look at the advancements in this technology, it's years and years just to kind of, and you know, like even field of view. I mean, you know, to even just get a few degrees wider in field of view, you know, it takes years or a decade, or, you know, it's been a very, very slow progression. And I would love to believe that there's a company out there, you know, quietly, you know, engineering away outside of public view that's going to just, you know, bust open the industry and jump onto the scene and shock us all. But given the fact that what I track are the, you know, OEMs, these original equipment manufacturers that make the individual components that are the technology within the products rather than the products themselves, I kind of have a pretty good idea of kind of like where the tech is at and what pace it's moving at. And it's slow. You know, I think Apple would have loved to have introduced a product. I mean, they wanted to introduce something in a glasses format in 2020. And I know, God, through their marketing department was just salivating to be able to market off of 2020. But 2020 vision. But, you know, 3 years later, and they're coming out with, you know, wouldn't say it's not a, you know,
Awesome.
a shoebox, but it's, you know, it's still a pretty bulky device.
Sure. Awesome. Well, I think we are running out of time here, but it was really, really neat to have you on, Chris. And thank you. Thank you so much for actually one more question. Just briefly, because we're running pretty late. How would you recommend someone creating their own augmented reality headset or starting their own company? Would you just deter them from that task, or is that a possible pursuit?
Yeah, I mean, you know, my attitude would be go for it, but you know, I'd be kind of curious as to what angle they want to come at it from. I mean, you know, on the one hand, you have companies like Vortec and Digilens, and you have all of these OEMs that make all of the components. And you know, if you had a good use case and you had, say, working as Vortec or whatever, some manufacturer that has, you know, sort of high build quality, you know, and you're able to raise the money, you could introduce something into the market, you know, that's I don't want to say every company out there is a commodity, but most of these smart glasses companies, they tend to have a core technology, and very often that, you know, that could very well be the lens, but you know, they'll have, like in some cases, it's just the software, you know, and so if all the internal components are from other suppliers, you know, it's like I said, I don't want to say all of this is commodity parts, but I mean, you could find all of the components to build smart glasses, so available on, you know, on the market if you can build the supply chain to put it together. Of course, the other angle is, are you saying inventing something? Like if you're, like, I think the one path to success is to, you know, like, look for a problem that the rest of the industry is trying to solve that other people aren't focusing on. And I think one of the, you know, just what my talk was about collimation optics, you know, I don't doubt to a lot of people that's probably a pretty boring subject, even to a lot of people that are in this industry, you know, or they're enthusiasts and everything. You know, like a lot of people ask me, like, oh, are you a gamer? And they like want to tell me all their favorite VR games. And I'm like, I'm kind of boring. I'm like, no, I'm not really a gamer. You know, you want to talk about neural optics? You know? And so if you find that there's like a problem that the industry is having, and you go like, oh, nobody's solved like this thing, you know, then go solve one small hard problem that provides a solution to the industry. You know, you probably find some success.
Cool. Awesome. And Chris, you're available for consulting and writing and sharing your research, just to share with.
Yeah, I mean, here's this. A lot of this is a passion project for me. I mean, I've done consulting work for. I have a few NDAs, so but I've sold research to Vuzix. I've sold research to Loomis. Google has purchased research from me. I've sold research to a lot of companies in space, both big and small. But the fact is, like my bread and butter is I'm a creative director. Like I'm a guy that does creative direction, and this is, you know, I do research in this space as my side hustle. Yeah,
Awesome.
I've worked for, you know, I was with telepathy for a couple of years, but that was years ago. And, you know, I was involved in the creation of AWE early on. I mean, Ori created the company and everything, but I was an organizer for the first couple of years. So, but I'm not, you know, this is a side hustle.
Awesome.
And hey, you know what? If you're a company that wants to have me turn it into a main hustle, then write me a big check.
Well, put your LinkedIn email in the chat in case anyone wants to reach out. It's always really neat having you on.
Oh, thank you.
Yeah, thank you so much, Chris. It was great having you there. And we're pretty over time now, but with that, we'll conclude tonight's meetup. Thank you all for joining. If there's any further questions, feel free to post in the chat, but we'll start winding down here. Thank you for joining. Cool. Thanks, Chris. I see your post. Amazing. Awesome. Thank you, everyone. Have a great night.
Thank you, Eddie. Have a good night.